Good morning to one and all. So today we will see center of mass, center of stiffness or center of rigidity, and effect of torsion and how we can incorporate the torsional force while designing the building for earthquake. So we have already seen during first module that how the torsion came, what are the causes of torsion, and how we can basically remove or reduce the torsional effect due to irregularities of the building. Irregular buildings generally are having torsion in them, right? So what we have decided that in order to reduce the effect of torsion, what we need to do? What we need to do? Yesterday also we have seen irregular buildings. So if we make regular buildings, then ultimately the torsional effect will be reduced, right? Right or wrong? आवाज जा रही है? Am I audible?
Yes, sir.
Yeah. So
Yes, sir.
yeah. So we will just go through basics. So first we will write center of mass. Center of mass, CM. फिगर हम बाद में ड्रॉ करेंगे. राइट डाउन the point through which the point through which the resultant of the masses of a system X, the point through which the resultant of the masses of a system X is known as center of mass. The point through which the resultant of the masses of a system X is known as center of mass means what it means? Write down the point corresponds to the center of gravity of masses of system. Correct? So this point corresponds to the center of gravity of masses of system. ठीक है? It is related to center of gravity CG, right?
Yes, sir.
For symmetry it will coincide.
Yes, sir.
So now write down earthquake induced lateral force. Earthquake induced lateral force on the floor. The earthquake induced lateral force on the floor is proportional to mass. Is proportional to mass. Full stop. Hence resultant of this force passes through the center of mass. Hence the resultant of this force passes through the center of mass. Now after paragraph change, write the floors having uniform distribution of mass, comma the center of mass coincides with the geometric center of the building. Correct? Any doubt? Shall we move ahead? Okay. The mass of elements located between two floors ब्रैकेट में, in bracket write say columns and walls for example. Say columns and wall for example. Bracket close is usually lumped equally between the two adjacent floors in inverse proportion to the distance of the mass from the floor. Is inverse proportion to the distance of the mass from the floor. This is how we calculated the seismic weight of the building. The floor mass is lumped, right? For each floor we have calculated. For column and walls, what we did, half above and half below. याद आ रहा है आप लोगों को?
Yes, sir.
So this is center of mass. Now write center of stiffness. Center of stiffness, CS, it is also called center of rigidity, CR. First we understood center of mass and second center of rigidity or stiffness. The point through which the resultant of the restoring forces of a system acts. The point through which the resultant of the restoring forces of a system acts is called center of stiffness.
Sir, please repeat.
The point through which the resultant of the restoring forces of a system acts. Center of mass में what happens? Center of mass में what was the definition of center of mass? Anyone can read out? It is the center of masses of the system and it is the center of restoring forces of the system, right? The point through which the resultant of the restoring forces of system acts is called center of stiffness. It is also known as center of rigidity. Okay, now change the para and write. For a one-story building, for a one story building, comma, center of stiffness in bracket write down C with S at bottom, CS, for a one story building center of stiffness is the point on the floor through which the lateral forces undergoes only rigid body translation with no rigid body rotation. So, what is rigid body translation and what is rigid body rotation? What happens here? Only rigid body translation is allowed or possible. So, what is rigid body translation?
So rigid body translation means sir, just joints होंगे सर उसी में ट्रांसलेशन होगा.
Every body moving with, yes. What is rigid body translation?
सर रिजिड बॉडी ट्रांसलेशन में जो बॉडी के जॉइंट्स हैं उनका ट्रांसलेशन होगा या पूरी बॉडी ट्रांसफर होगी, मेंबर तो नहीं होंगे सर, मतलब मेंबर रिजिड होंगे सर.
Every point moves with same velocity, same distance, right?
Yes sir.
Is it correct?
Yes sir.
So, what happens in rigid body translation? You just not need to write out, you just understand that it is the simplest motion of a rigid body where all the points move with same velocity and acceleration while shifting. And what about rigid body rotation? All the points move in a circle with equal angle, right?
Yes sir.
Okay, understood? What is rigid body translation? What is rigid body rotation?
Yes sir.
Okay, now write. Up to what point you have wrote?
Sir, rigid body translation with no rigid body rotation.
With no rigid body rotation. I will read out once again. For a one story building, center of stiffness is the point on the floor through which the lateral force undergoes only rigid body translation with no rigid body rotation. Now write down the building as a whole or its various blocks should be kept. The building as a whole or its various blocks should be kept unsymmetrical or symmetrical. What should we write? Unsymmetrical or symmetrical? To avoid the center of stiffness. Yes?
The various block unsymmetrical.
Should be kept unsymmetrical to reduce the center of stiffness. To match the center of stiffness and center of mass, what should we need to do? We should keep the body symmetrical or unsymmetrical, or to reduce the torsional effect. What we need to do? Symmetrical, na?
Symmetrical. Yes, sir, symmetrical se torsion come.
Yeah. So right. The building as a whole or its various blocks should be kept symmetrical about the axis. Full stop. Asymmetry leads to torsion during earthquake and is dangerous. Now write static eccentricity. ESI, static eccentricity. Write down, it is the distance between the center of mass, it is the distance between the center of mass and center of stiffness of floor I may be 1, 2, 3, 4 depending upon the number of stories. So, static eccentricity, what you have written? It is the distance between the center of mass and center of stiffness of floor I. Now write down design eccentricity. EDI. Write down, it is the value of eccentricity, to be used, at floor I in torsion calculation for design. It is the value of eccentricity to be used at floor I in torsion calculation for design. So, we have to check this value in code. We will see this also. Now, first draw this figure. The black one is our block and second portion is displaced block, right. So, this one is earthquake force, this is direction of earthquake force. Point 2 is, you just write down here, 1 is earthquake force, 2 is center of stiffness or resisting force, third is center of mass, और क्या बोल सकते हैं, what we can say, center of gravity or the applied inertia force. So you have to calculate, you have to check whether you have to find out the center of stiffness, center of mass, then you have to check whether it is coincide or not coincide, and if it is not coincide then we have to calculate either static eccentricity and design eccentricity. For what? For calculation of, or to take the torsional effect of torsional force in the block or building, right? Write down this figure. T is twist, now after this figure make this one also. Just draw these figures. This is 2 number, that is center of stiffness, center of mass, and this is earthquake force. Torsional torsion in unsymmetrical plans. Figure is completed. Okay. Everyone has done, or should I wait for 1 or 2 minutes?
1 minute, sir.
Okay.
Yes, sir.
Okay. So you have to just write about these figures only. Okay. To understand what is center of mass, how it acts, center of stiffness, and how torsion came. So you just write down irregularities. Which one? Irregularities of mass, comma stiffness, irregularities of mass, comma stiffness and strength in a building can result in significant torsional response. However, torsion arises from the building layout. When the center of mass and center of rigidity does not coincides. In both the figures, what we have observed, that center of stiffness 2 and center of mass 3 are not coinciding with each other. It means what will affect the building? It may be due to, what will affect? Torsion. है ना? It may be due to irregularity in mass, stiffness or strength, right? So in both the cases, what we are observing, that point 2 and point 3, that is center of stiffness and center of mass, both are not coinciding with each other, right?
Yes.
Okay. Now move ahead. If there is torsion comma, what happen? Due to torsion, building will rotate or twist. So if there is torsion, comma, the building will rotate about which point? Center of rigidity, right? The building will rotate about its center of rigidity, comma, due to the torsional moment, about the central of structural resistance, due to the torsional moment about the center of structural resistance. Inertia force will take place during earthquake. Ultimately, to resist this force, body will resist the force, na?
Yes, sir.
So it will rotate about its center of stiffness. Okay, now write down the earthquake force. The earthquake force bracket में inertia force, the earthquake force in bracket inertia force in bracket close acts on the now on which point earthquake force will act? Center of mass. So write the earthquake force bracket में inertia force bracket close acts on the center of mass or center of gravity. Both are the same thing. In bracket write down point number. Which point it is? 2 or 3? 3. Point 3, comma. While the resisting force acts along the direction of force or opposite? Opposite. While the resisting force act opposite to the inertia force. And what that point? On which point it will act? 2. Act opposite to the inertia force on the center of stiffness. In bracket point 2. And ultimately what it results? Twisting effect will come, right?
Okay.
So while the resisting force act opposite to the inertia force on the center of stiffness point 2, causing torsional moment at the center of stiffness, in bracket point 2, and the building will rotate about the center of stiffness. Correct? Okay. Clear to everyone?
Yes, sir.
Everyone has to say na then?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Now write down. While designing the building for earthquake resistance, comma, attempt should be made to locate the building while designing the building for earthquake resistance, comma, attempt should be made to locate the building masses and structural element uniformly in the layout. I will read it once again. While designing the building for earthquake resistance, comma, attempt should be made to locate the building masses and structural element uniformly in the layout, comma, so that the distance between the center of mass, and center of stiffness, that is static eccentricity, and center of stiffness, that is static eccentricity, is as minimum as possible or is as maximum as possible. Which is correct? Minimum. Is as minimum as possible. So, just underline this line that the distance between the center of mass and the center of stiffness, that is static eccentricity, is as minimum as possible. So that either no torsional force will come or it will be very less. Now let us talk about something about the forces, right. So write down design forces calculated as per clause 7.6 and 7.7.5. So which forces we have calculated with the help of this clause?
So which clause?
7.6 and 7.7.5. You have to see, we have solved numericals.
Yes, sir.
So which forces are these? Okay, we will see. If you have code, just go through.
Lateral forces.
Yes. What is 7.6? We have calculated base shear, na? Equivalent static method with the help of equivalent static method. And 7.7.5 is what?
Base shear.
Response spectrum method. Either we can calculate with the help of static method, static coefficient method, or response spectrum method. So whatever the method we are used to calculate the force. Now what we have to do? What we have to do? Write down. So you understand now what is clause 7.6 is for and what 7.7.5 is for. One is static coefficient method, another one is response spectrum method for calculation of lateral forces, right?
Yes, sir.
Okay. So write design forces calculated as per 7.6 and 7.7.5 shall be applied at the center of mass appropriately displaced, comma, so as to cause design eccentricity, between the displaced center of mass and center of rigidity. Full stop. The design eccentricity, in bracket you write EDI, to be used at floor I shall be taken as per part 1 2016, IES 1893 part 1 2016, clause 7.8.2, clause 7.8.2, page number 25. As now we just go what that clause is. Now here it is 7.8. torsion, provision shall be made in all buildings for increase in shear forces on lateral forces resisting elements resulting from twisting about the vertical axis of the building arising due to eccentricity between the center of mass and center of resistance at the floor levels. Is it okay up to this point? Now we knew what is center of mass, what is center of resistance, right? Center of resistance is nothing but center of stiffness, right?
Yes, sir.
So what it is written, arising due to eccentricity between the center of mass and center of resistance at the floor levels. We have also mentioned that at particular floor, that is floor ith, it may be first, second, third, fourth, right? The design forces calculated as in section 7.6, that is static coefficient method, and 7.7.5, which is response spectrum method, shall be applied at the displaced center of mass so as to cause design eccentricity as given in 7.8.2 between the displaced center of mass and center of resistance. So we have to calculate design eccentricity. How we need to calculate? While performing structural analysis by the seismic coefficient method or the response spectrum method, the design eccentricity EDI to be used at the floor I shall be taken as, you just write down this formula, 1.5 ESI plus 0.05 BI or ESI minus 0.05 BI. Write down this formula. Is it clear?
Yes.
And what we have to see in this, whichever gives the more severe effect, whichever gives the more severe effect on lateral force resisting elements, right? Correct? Is it okay?
Yes, sir.
Okay. Now you just write down. Have you written this formula?
Yes, sir.
Okay. Now where ESI is equal to static eccentricity at floor I. You write down this also. Static eccentricity at floor I, which is equal to distance between the center of mass and center of resistance, and BI is equal to floor plan dimension of floor I perpendicular to the direction of force. Right? Everyone has written it?
Yes, sir.
Okay. Now in equation we have write 1.5. So 1.5 represents dynamic amplification factor, which is taken to account for the increased stresses and strains that occur when a load is applied suddenly to a vibrating system. Okay. For this we have taken this 1.5 amplification factor, and 0.05 BI represents the extent of accidental eccentricity, right? And when we are calculating the forces through time-tree analysis, time-tree method, then this 1.5 need not to be used, correct? Because this will be taken care in the method only. Okay. Time-tree method, we knew what is time-tree. Everyone knows this? Non-linear dynamic analysis, right? Okay. Is it okay?
Yes, sir.
Up to this point, you just go through what we have discussed today and ask me if you have any difficulties or any doubts. Just go through, we will take 2 to 3 minutes for this. Just go through what you have written. If you have any difficulty, you can ask me right now only. Okay, any doubts? If you have any doubts, I can explain this right now only. Or shall we move ahead? Okay. Now you just go through this diaphragm. What is diaphragm? So now we will see what is rigid diaphragm, what is flexible diaphragm, and torsionally coupled and uncoupled systems, and then the numericals or problems related to calculation of torsional forces. So shall we start from today onwards or in the next class? जी
अभी कर सकते हैं, टाइम तो बहुत है।
Okay, so you just write down. Now we will move for torsionally coupled and uncoupled system. Torsionally coupled and uncoupled systems. You write down. Torsion responses in a structure arises due to torsion responses in a structure arises due to what are the causes? जी first we have seen eccentricity in the mass and stiffness distribution, right?
Yes, sir.
So write down eccentricity in the mass and stiffness distribution. Second B point, accidental causes like uncertain live load distribution, comma, eccentricity between assumed and actual stiffness and mass. If it varies, then ultimately torsion will come if they are not coinciding, and we assume that, suppose we assume that they are coinciding and they are not coinciding, then torsion will act. Comma, rotational component of ground motion, that is vertical axis, comma, uncertain dead load due to variation in materials and workmanship. Uncertain dead load due to variation in materials and workmanship, comma, subsequent alteration may be made in a building, for example addition of walls, etc. So first point, जी बिल हो सकता है सर, दिस शिफ्टिंग ऑफ मास विल टेक्स प्लेस इन दैट केस, एंड इवन उस केस में तो जो है शिफ्टिंग ऑफ लोड पाथ विल ऑल्सो टेक प्लेस, इट इज पॉसिबल. So write down torsionally coupled system, and secondly columns, removal of columns or shifting of columns should be avoided as far as possible, because it may cause global failure of the structure. So torsionally coupled system. The structural system for which center of mass and center of stiffness, the structural system for which center of mass and center of stiffness does not coincide, is called torsionally coupled system. ये एक डायरेक्शन है, दूसरा डायरेक्शन तो अल्टीमेटली कपल फॉर्म हो गया. इसके कारण क्या हुआ, टॉर्शन आया, राइट. सेकंड, torsionally uncoupled system. इसमें क्या होगा? Uncoupled means eccentricity 0, coincide with each other. So write down the structural system for which center of mass and center of stiffness coincide, that is CM and CS coincides, E is equal to 0. Coincide, that is bracket में, that is E equal to 0, is called torsionally uncoupled system. Torsionally uncoupled system. Right? Shall we move ahead?
Yes.
Okay.
Yes, sir.
So we will solve one problem. Write down. Carry out lateral load distribution. Carry out lateral load distribution to shear wall. Carry out lateral load distribution to shear wall of one story building shown in figure, comma, total lateral force of 1000 kilonewton acts in y direction, total lateral force of 1000 kilonewton acts in y direction. Consider rigid diaphragm action. Slab thickness is equal to 15 centimeter. E is equal to 25,500 Newton per mm square. K is what? Stiffness. 2300 into 10 to the power 3 Newton per mm. So you just make this figure. K की वैल्यू है 2300 into 10 to the power 3 Newton per mm. Is it clear now? Stiffness is K, this shear of stiffness is 0.2 K, and again it is K. This is X, then this is Y. So force is acting in y direction. Thousand kilonewton. If we take this friction, this is B, this is stiffness K, .2 K, and again this is K. Right, so solution, given data, slab thickness is equal to 15 centimeter is equal to 150 mm. Right? This is 8 meter. E is given, stiffness is given. Then what we have to find out? I for diaphragm. What is the formula? BD cube by 12.
Yes, sir.
B is 150. For diaphragm D perpendicular, D is 8000 mm. Right? So calculate I. 150 into 8000 cube by 12. What is the value?
6.4 into 10 to the power 12 mm.
6.4 into 10 to the power 12 mm. Mm cube into mm. So mm to the power 4. Okay. Now this I we knew, force we knew. Now what we have to calculate? Distribution of forces. Carry out lateral load distribution, right? So what will be the value? How we will distribute the load? This is K1. K1 is equal to K, K2 is equal to 0.2 K, K3 is equal to K. So we have to distribute this lateral force with respect to their individual stiffness, right? Right or wrong? So what will be the value? Contribution P is equal to K delta. If it is unit delta, then the force will be distributed with respect to the stiffness.
Yes, sir.
So K1 upon K1 plus K2 plus K3 into force, right?
Yes, sir.
So force in spring 1 That is total force.
Okay.
So force in spring 1 is equal to K1 upon K1 plus K2 plus K3 into force. तो कितना है K अपॉन K प्लस 0.2 K प्लस K इंटू 1000. Right or wrong?
Yes, sir. 400 kilonewton, sir.
4
400 kilonewton, 200 kilonewton and 400 kilonewton.
ये कितना हुआ टोटल 2.2 के
2.5.
2.5 नहीं है 0.2 के
2.2. Okay, sorry sir, मैंने 0.5.
के अपॉन 2.2 के इंटू 1000. कैसे कैंसिल हो गया 1000 डिवाइडेड बाय 2.2.
454.5.
ये किस में था किलो न्यूटन में. तो हमारे पास फोर्स क्या है वैल्यू ऑफ फोर्स इज इन किलो न्यूटन. नाउ फोर्स इन स्प्रिंग 2 you just calculate and tell me. Yes, 0.2 upon 2.2 K into 1000.
90.9.
Force in spring 2, it will be 90 kilonewton. You just check once again. यहाँ पर क्या होगा K2 अपॉन K1 प्लस K2 प्लस K3 इंटू फोर्स P. तो व्हाट इज द वैल्यू 0.2 K अपॉन 2.2 K इंटू 1000. व्हाट इज द वैल्यू
455 in third.
into it is 90 kilonewton.
Into 90 kilonewton.
In 3 again for spring 3 it is 455 kilonewton. So if you have to recheck or cross check, then total sum must be equal to force P. So you just write 90 plus 455 plus 455. What is the value? Total force is equal to 455 plus 90 plus 455 is equal to 1000 kilonewton. Matches with our force value. Right? So you just go through. Now we will see some more numericals in next class. If you have any difficulty, you just ask me right now only. Sir, any difficulty? जी. So shall we stop here today?
Yes, sir.
Okay.
Yes, sir.
So you just go through all the things that we have done today, and in the next class we will refer what we have studied today for solving the numericals. Okay. So we will end here. Yeah. Thank you very much.
Thank you, sir. Thank you, sir.
Okay.
Thank you, sir. Thank you, sir.